Part 2 of the 4.7 notes has us sitting here faced with this equation, x squared plus y squared equals 1. And we want to try to get it into calculator mode. So we want to somehow solve for this y. So the first thing we want to chip away is the x squared. We're going to subtract x squared from both sides. And your next line would look like that. Y squared equals 1 minus x squared. And then how do you undo squaring? Square rooting. So we're going to take the square root of both sides. Here's how you write it. The square root of y squared is just 1 y, just 1y, sorry. Y. On the right side, remember the old rule. This is a little side note here. When we had x squared equals 36, and you square rooted both sides, we got plus or minus 6. Some of you got burned by that on the test, right? Pre-remediation. But now we have plus or minus 6. So when you do it here, you get plus or minus the square root of, leave 1 minus x squared alone on the inside. Don't square root the 1. Don't square root the x. Just leave them alone. This is not the square root of 1 minus the square root of x squared. You do not rewrite it like that. It's just not true. So it's going to disappear. That's the equation that we can graph to make a circle on our calculator. Remember how I said it was going to be a lot like trying to make the parabola on its side by doing the top half with the positive and the bottom half with the minus. So let's see what happens when we go to the calculator and we go to y equals. Y1 is going to be the positive square root of 1 minus x squared. Close it. The bottom half is going to be the negative square root of 1 minus x squared. And before you hit graph, I have some advice. We have a new zoom to use. You know how we sometimes use Zoom Stat or Zoom 6 for Zoom Standard? Well, the one that I want you to use is Zoom Square. What Zoom Square does is it makes your rectangular screen appear to be square. You know that this is not, does everybody agree that this is not a square screen? Okay? It's not even close to square. It's longer than it is tall, right? It's wider than it is tall. So it's not a square. But then when you go to make a graph, right, it distorts the picture because it goes 10 units to the right and 10 units up, but it's distorted because 10 horizontally is different than 10 vertically. So it doesn't produce a true picture. To fix that, what you can do is what's called Zoom Square. So let's hit Zoom 5 on my calculator, on yours. And it should make the top half and the bottom half of that cute little circle there. Okay? We've been discussing how you can make this circle larger because it's so small on the screen. The reason it's so small is because its radius is only 1. You could zoom in to see a larger circle, but let's actually make it larger. And to do that, let's explore a little bit. If we want the radius to be 2, change the little 1 to a 4 in both equations. If you don't do it in both equations, your top half will get bigger, but the bottom half won't. When you graph it, you should see a circle now with radius 2. Another thing that you're going to find is as it makes the circle larger, it's going to appear to not connect right there. That's just due to the weak graphics of these calculators. They're not Xboxes. They're more like Ataris. Okay? It's a quote C, though, I suppose. All right, so let's keep going here. Let's try to make the radius 3 You want to jump to 5? Okay. To make the radius 5, you want that number to be 25. If you don't want to retype over all of your work, you could do second insert 25. Delete the 4. Again, if you don't want to retype your entire equation, you can second insert a 25 and delete the 4. This should make a circle with a radius 5. And again, the little Atari, known as our calculator, will not connect them. It has a difficult time drawing vertical lines. You know why? Vertical lines are not functions, so it refuses to draw them. So when it gets vertical like that, it has a difficult time with it. All right, so let's get back to the question, why 25 for radius 5, why 9 for radius 3, and why 4 for radius 2? Where does the equation for a circle come from again? What famous theorem? The Pythagorean theorem. And what we have is, I'll do this kind of quickly. We have a circle with a triangle in it, and that triangle is known as a right triangle, right? Horizontal distance x, vertical distance y. Hypotenuse was 1, but we want it to get larger. We wanted the radius to be 2. So if that was the case, you would have x squared plus y squared equals 2 squared, or c squared. That's where the 4 comes from. If you want the radius to be 12, it would be x squared plus y squared equals 12 squared, which is 144. So the radius needs to be squared in the equation. Next, how do you move it? We want to move the circle left, right, up, and down. Well, on this page, on my smartboard, but not on your paper, I drew the circles that they want you to make the equation for. Does that sound right? I'm not sure. Okay, so they have the circles. I drew them for you. They wanted a circle centered at 4, 2, and that is the blue one here. At 4, 2 is its center. And they wanted the radius to be 3. So there's our visual. You can see it. Well, let's tackle the 3 first. How do you take the unit circle and create the radius 3? What's going to be over here? A 9, or 3 squared. So we have that. That would have created, whoops, it's all ruined now. They wanted it 4, 2, there we go. That would have created this. How do we get it to shift right and up? So we need it to shift over, oops, wrong one, over and up. How do we get it to go there? Any ideas? How do you get a parabola to shift right? 3. Inside the parentheses, with whom? X. How do you make something go right 3? Then square it. Now, we need to tackle the up. How do you make it move up 1? Well, with the parabola, this is how up 1 would occur. With a radical, this is how up 1 would look. And with an absolute value, this is how up 1 would look. How would all of those look if the 1 was over here with y? Right? If the shifter, 1, was with y in y's neighborhood, they would all be y what? -1. So how do you think you take a circle and move it up 1? What do you put with y? Y -1. That would create this circle. Let's try it on our calculator. by getting y by itself and then graphing it. See if it produces this blue circle. I'm going to pause the video, try to get y by itself, and graph it. And we're back, and a very observant student noticed that we shifted it right 3 and up 1, and we were supposed to shift it right 4 and up 2. So let's pretend that this was 3, 1. Now everything's good. It's okay. So you know everything would be exactly the same, except the 3 would be a 4 and the 1 would be a 2. Sorry about that. So again, this circle should be here at 3, 1. All right. But we have it solved. We have it solved, and we are ready to put it into the calculator. So let's take those 2 equations and put them in your calculator, and that will conclude this lesson. Press pause, check it out, see if it works. Here we are. There's the equation ready to be graphed on our calculator. We have the square root of 9 minus x minus 3 squared plus 1, and then the negative version of the same thing. When you graph it, you should see a circle with radius 3 shifted right 3 up 1. It's a miracle. It worked. Even though we were supposed to shift it right 4 and up 2. How would that look here? Change the 3 to a 4. Change the 1 to a 2. And to correctly answer the question, right 4 up 2, it would look like that. That concludes the lesson on circles. The next video will discuss how you make it an ellipse.